All right. Howdy, listeners.
Greetings, Internet.
Greetings. So today was a big day in Silicon. One of the companies that we like to talk about had their technology conference. This is Nvidia we're talking about, in case anybody hasn't followed. They had GTC today, in which a flurry of announcements were made. Obviously, many of them around AI, because who's not talking about AI these days if you're not in semiconductors? Oh, Jay's not. He raised his hand. Friendly reminder, we also have things on YouTube in case you want to see our faces. I turned my background to green today, in which Jay made fun of me of, in honor of us talking about NVIDIA. But I want to start with a key question philosophically. I think I might know the answer, but regardless, I want to ask it. So one of Jensen's main points, so CEO of NVIDIA, is that AI is having its iPhone moment. And so I'm curious, one, do you agree with that? Or two, would you put it a different way in terms of this sort of, call it, inflection point that we're having around AI?
Yeah, so that was certainly a big topic for Jensen Huang. I mean, I think he mentioned it 6 times in his keynote. He
Yep.
kept saying that this is the iPhone moment. And I get it. I think I'm not quite convinced we're there yet. I have like unquestionably the technical achievement around GPT and all these other LLMs is astounding. It's some incredible stuff they can do. I'm just not convinced that this is something that's going to like reshape the world the way the iPhone did. Um, happy to be wrong on this, but let's bookmark this and come back in a year and see if we're laughing at me.
Yeah. I mean, I go multiple ways on this. I mean, I think again, right? You're right in the context of the iPhone was sort of pivotal from a boom standpoint. One, with a new kind of category of computing. I think what we've talked about before here is we're talking about computing in a different way. And I made this point with an article I wrote last week where I sort of said, this is the year that AI goes mainstream. And the point that I made was it's going to diffuse very quickly because it can be done on all the devices that we have today. You don't need new hardware and the end client level to take advantage of what's going on in the back end and development. And so because of that, it's going to diffuse very, very quickly. And that I think is a little bit different than, well, to take advantage of this developer doom, I need to buy a new piece of hardware, in this case, a smartphone. We're going to be able to do all this. Whatever's innovative in 6 months, we're going to be able to do it on the devices we have.
Yeah, I think that's right. I also think in terms of new modes of living and new business models, I'm not convinced that AI is exactly doing that. One of the things that was very prominent in the keynote and a lot of the other sessions is all the people who are using AI, and we should come back and talk about all the people, all these lists of people. But like they talked about drug discovery, or somebody was, I think BMW was designing a new factory using AI. And my thought was, before AI existed, you were doing that already. AI makes it better, but it's not, I mean, and arguably much better, but I don't think you're fundamentally changing the way you're, organizing your whole life. As opposed to an iPhone or a smartphone, when, like just so many, just the sort of immediate access to information changes so many different things in the world. This is an improvement, but it's not necessarily new.
Yeah.
Right? It's like I said a couple episodes ago. If you had the same conversation and you just replaced the word AI with software, it would
Yes.
be true. It would also be less exciting. You wouldn't have stirring music in the background.
Yes. No, I think that's a great perspective. Okay, so that was on the overall framing and positioning. Another theme that I caught, and I thought this was really interesting because, Jensen didn't just come out and say, I hate x86, but in a lot of the things that he said, announcement wise or shunned of the processor, right? He like took the little x86 CPU processors and kind of put them in a little corner and was like, they're okay for there, but if you want to minimize your cost, if you want to minimize your power savings, there's better places to do that. And you can do those things on these GPUs, or you can do them on some of the accelerator cards that they're launching, like the L4. And so I kind of took this like, man, I mean, he is really, I mean, I think we all who know Jensen's past and himself, like there is no love for x86, but really in the way that they are architecting their products, and even how they're moving in the Grace Hopper ARM CPU into some of these products, it really feels like this is a continued all-out assault on x86 in the data center.
I would almost term it a victory lap,
Okay.
because there was one product sort of late in the keynote where he mentioned, oh, this is going to be this module and it's going to have an Intel CPU in it. And I thought, wow, that was very gracious, it was very magnanimous of him in victory to award them this consolation prize, because
Yes.
everything else was just like, like this is so much better than he explicitly called out, like this is better than the best x86,
Yeah.
which is important because it's not even better than Intel. He's implying it's better than AMD who has
Yeah.
advanced process. So yeah, I think you're right. This is very, very clearly x86 barely matters anymore kind of moment.
Yeah, yeah, and philosophically, another kind of positioning statement he used that I actually really like, because in the vein of saying, okay, look, let's have the best product in the data center for the best workload or the best acceleration of that workload. One of the things that I think was just wrapped into all of the different industries that they talked about was how they are via, in this case, GPU architectures or their software stack, accelerating workloads, but there's more workloads that need to be accelerated. So he used sort of this frame: every industry needs to accelerate every workload. I think he said that like 2 or 3 times. And I thought that was really interesting, because it shows, one, how much growth there is, but still just the point that we aren't optimizing processes on the back end. Every business isn't as efficient as possible. And yes, there's a mix of CPU, GPU, NPU. I mean, you name it, right? That plays into that. But I thought positioning wise, that was really clever, right? Coming out and saying lots of industries need to accelerate workloads. We're not even close. And that's why we believe so much in our roadmap and our software stack, etc.
Yeah, it gelled for me something, because he's been in the press a lot the past year or so saying Moore's law is dead, right? Which I don't think is accurate, but he's been saying that a lot, so I have to think about it. And I finally understood today why he's saying that, because I don't think he's explicitly talking about sort of lithography. What he's really saying is general compute. I'd probably phrase it as general compute is dead, right? And so you need to accelerate things. You need to take a more custom approach. You need to sort of tailor your solution to the industry vertical, and it makes tons of sense to do that on a an Nvidia GPU or an Nvidia system.
I think that's well put. And interestingly, he did not say today that Moore's law is dead. He said it slows down, even though I know he has publicly said it's dead. The safe non confrontational way to say this is just to say it's slowed down, because everyone agrees with that. So I when he kept like building it up, I thought for sure he was going to say Moore's law is dead, because he was like, yeah, Moore's law was the driver of the industry. I was like, here it comes, and then he said slows down. So I was like, oh, okay. But on this point of these accelerating workloads, I thought it was really interesting that kind of one of the announcements that caught me was is cuLitho, which is essentially accelerating computational lithography that it looks like a number of the manufacturers like ASML, TSMC are going to use, having access to that library. But the way that GPUs then, he was saying, or could be used to accelerate this in manufacturing and lithography, I thought was super interesting. And then again, an example of an industry that can accelerate workloads via GPUs, and hence they have this cuLitho announcement.
So I think two takes from that. One is, I think there's a broader point, and to me this was the theme of the whole show, was every announcement was a partner. We're doing this incredible thing with this other company, right? I looked it up today. They have 37 press releases out today, which is staggering in its own right. Way more than half, probably 2/3 of them, explicitly mention a partner in the headline, right? So vast amount of attention focused on who they're working with, which is again sort of customizing to a vertical solution. And I think that's a really important theme. And then we turn to Kulitho, which is like almost a perfect example of this. It's almost too perfect because it so explicitly is in their best interest to improve lithography. But it was really fascinating what they're talking about. Like, he had that moving diagram of how the ASML EUV machine
Yeah.
worked, which I thought was super fascinating. But then when they actually got down to the sort of nitty gritty of what Kulitho can do, like, I mean, it's an advanced course in lithography right there.
Yep.
And just the idea that like, oh, the mask doesn't look like the circuit. You have to like, light does strange things, and you need to sort of computationally address those. And yeah, let's accelerate that and do it even better. I mean, that's to me like it's really abstract and esoteric. You have to go through a couple layers of semiconductor background to get there. But it's, to me, that's like that's the chat GPT equivalent. It's like something really
Yeah.
useful, right? And then you're not writing, rap songs or iambic pentameter application essays. You're doing something very creative in a sense, but just with crazy complicated math on a crazy complicated manufacturing process.
Yeah. Yeah. Well, and on this theme that you touched on, that I think is also kind of the underlying point of this, is there was the hardware product that they were talking about that played a role in said area. Then there was the software enablement, the platform or the software standards that were being used that NVIDIA supports. And then in some cases, there were now services really on top of this, as it looks like NVIDIA is moving more, towards some forms of services, like, DGX Cloud was an example of that, where, they're holding hybrid training platforms. They had their foundational models, which I think is worth talking about because that was super interesting, trying to just democratize and make sure more people have equal access to large language models, not just OpenAI and Google and others. And so you see that there was hardware, there was the software component, and then there was a services component in some as well in some of these verticals. And that's kind of the first time I've seen NVIDIA present that whole hardware software services strategy. I know internally they like to be thought of as a platform company. You can easily think of them as a platform company, but to really cement it, right? It's not just the hardware. We're not just a pure play semiconductor company. We have the software ecosystem, and now we have services that run on top of that. But it really is all tightly integrated. It's not fragmented out in terms of like piecemeal. It's like you need these stacks together, and when you do, you get to these accelerated efficiencies that they talk about.
Yeah, I know they announced Omniverse last year, I think at their analyst day. And I remember when it first came out, I thought like Omniverse, that sounds kind of weird. Like there wasn't a lot of detail, and like my obvious question is, aren't you going to end up competing with your biggest customers? And today, I think what he delivered or what they delivered was a sort of very fully flushed out, concept of what a program for what all of this means, not just Omniverse, but sort of their broad software system solution platform really looked like. And I certainly came away thinking like, oh, these guys have really thought through this pretty well. There's a lot of detail here. There's a lot of very tangible, specific use cases. Here's what customers are going to do with it. And I thought that was yeah, to your point, like this is a real product. They're going to do all these things.
Right.
And
Right.
right, because companies talk about these kinds of things all the time. Oh, we're a solutions provider, right? But are you, right? Or are you just selling a 15 cent, you know, part? And I think, to their credit and to Jensen's credit, like they will deliver on this stuff. And I think that was on display today. They actually, they put their money where their mouth was, I guess is how you'd say it.
Yeah. And from a holistic standpoint, they've got a lot that really, again, it goes beyond just the hardware, right? I mean, it's nice, like you said, Omniverse is interesting. Some of the applications they talked about today, like BMW building a factory, you can able to run simulations on those factories, right? Because it's essentially a digital twin of something you have currently or something you want to build, and so you can test things, test efficiencies without the grandiose scale. Like there's applications that go beyond, right? Just whether or not they push GPUs. Like that's real world value just from a services standpoint. Yes, it takes GPUs, but there's that software services angle that by itself is actually really interesting.
Yeah, I think one of the things that surprised me about this call is how much I learned about other subjects today. Like I mentioned the EUV machine, like, oh, I'd never seen one working,
Yeah.
animated. But it was other things too. It was like, how does the drug discovery process work? Like somebody walked through all the steps of it. How does a factory get done? Like I thought that like that factory teleconferencing, I thought that was a little cheesy, but at the same time, I was like, oh yeah, you have to move these machines around. And there's all these trade-offs, and I can see how this helps things a lot. It was really interesting to me, like how many use cases there are, and how this could help, and how these things move forward.
Yeah.
And you do it at a systems level. It's just they're providing more than just the chips.
Yeah. So let's talk again a philosophical point that was made that I'm sort of curious, your take on, because I'm not sure I agree, even though I understand why Jensen's positioning this way and Nvidia likes this idea. But at the same time, it's also very, if this is the world that we move to, it's very good for NVIDIA, but that the vast majority of this compute takes place on the GPUs. He was talking about inference, not just the training or the deep mind. So that, again, that's a great world. And he shows a picture where it's like, hey, you can get rid of all these CPUs if you just do all of this. Like, I get why that's there, but philosophically, like I said, I'm not sure I agree that it's just great that we do everything on the GPU. So philosophically, I'm lobbing that one at Yuri. Do you agree? All these things are best on the GPU.
I think, this is the big question in front of semis today is who's going to own the inference market? Right? I've talked about this before. Training is NVIDIA's.
Yeah.
It's NVIDIA's to lose, and I don't see anyone else really challenging for it anytime soon. So then the question is what the opportunity is in inference. And I think that's where a lot of the fight is going to be. I think NVIDIA looks incredibly well positioned to do inference in the data center.
Yes.
But I think, they're going to have to go up against some of their customers on that because some of them have a different view or want to do it themselves. And then there's sort of the edge is left over, like the inference on the edge, and that's going to be a huge category, which it's not really their market, so it's okay. But I ask myself a lot, like, what's going to be left over for everyone else?
Yeah.
If NVIDIA and Amazon and Google are going to take data center inference,
yeah,
I'm not sure who's going
I'm
to challenge
with you
them.
on the same part. I mean, there's been multiple reports coming out from the sell side, just looking at the cost analysis of a lot of these large language models, and similarly, they make the point, right? You've got a fraction of the market in terms of value amount, call it 15-20%. That's really GPUs, but the rest of the market is for inference, and so that's really the question, right? But it makes sense for NVIDIA to say, look, get rid of all of these unnecessary CPUs. That's just let them do what they should do. In fact, the way that Jensen positioned it is free GPUs for revenue generating workloads. So whatever you do out there that's just going to make money, great. But all of that nitty gritty work, the GPU can eliminate those CPUs, or to some degree, they've got these hybrid architectures where they have a CPU tied with their GPU and memory to again handle some level of inference and training. But it really is trying to position themselves to absorb that market as well with the value that the GPU brings if you just also do inference on those clusters.
Yeah, I think it makes a lot of sense to run this on GPU, right? Because LLMs, AI in general, are massively
Parallelized.
parallelizable. Yeah, they're good for parallel processing, and so easy to see how running on a GPU is superior to CPU, and it's just a question of custom ASIC or just ASIC, an AI ASIC versus NVIDIA, and it's been really fascinating to watch how a few years ago I think people would have assumed that we'd have a lot more on AI ASICs, and NVIDIA is just walking away with big chunks of the market continuously and taking share back from internal workloads in some case.
Yeah.
They've executed really, really well on that. So
Yeah.
they're the one to watch.
Yeah, I mean, and they had a lot of products that again did multiple things, right? They had some of their new cards like the L4 and the L40 were not just AI as a positioning; it was also video streaming, video encode, transcode. graphics optimization, graphics rendering. So it's kind of like, you could take these slot cards, put them in, cover a range of bases, still has all the software support, but in moving the needle in terms of all those applications, because it's not just the AI, but showing how each part of that product adds value to a different segment, I thought was showing the diversity, which was kind of, right, I think the point, right? The diversity of general purpose compute on GPUs that can be done.
Yeah, and I thought that video encoding piece was I keyed in on that too because my all-time favorite chip right now is the Google VCU,
Yeah.
right? And Google created that chip specifically for YouTube, right? It's their own chip. It was designed by the YouTube engineers, couldn't get any more custom, and they essentially created a category of product that didn't exist before. Everyone had been using CPU until then, and it's always interesting me that like Nvidia says, no, you don't really need a VCU. You can just do it here. It's a really good. It's going to be a textbook study of whether merchant versus internal silicon is going to win out in a sort of large but niche segment.
Right. What did you make? I was just curious because this kind of struck me as interesting, and I've seen a little bit of analysis come in about their decision to tie themselves with the L4 to the tensor unit. Which again, it sounds like it's specifically positioned as inference video accelerator, but I just thought it was interesting that they've made a decision on Tensor, and that's collaboration with Google. And yes, for now, it's going to run in Google Cloud. But I was just kind of interested that in your take, that's how they're tying themselves, if you will, at this point to Google.
I think my very glib answer is that. Yes, for Google, they'll do Tensor, and for everyone else, they already have CUDA, right? And all of the extensions that come with that. So I would look at this not as them turning away from other approaches. This is just adding one more library, if you will, to what they are. I mean, everything else is on CUDA, and hey, if we have to support Tensor to win Google, let's support Tensor.
Yeah.
Right. Very customer centric.
Yeah. Yeah. The other thing that was kind of subtle, I mean, it didn't come out directly in keynote verbiage, but was just this idea of the democratization of these large language models, and in particular, kind of this view of how a hybrid large language model works, right? And you just use like one of their foundational models, which is Nemo, for example, or BioNemo, which is another example, because that's. For BioNemo, for example, it doesn't need to be a trillion parameters. It can be partially a small language model, generally trained on biology or whatever the science is, and then the hybrid part of that comes into Research Institute, has data of their own, trains their own model on one of these GPUs, and now they have the combination of their proprietary data with sort of an open LLM, in this case biology, and then to some degree use that as their foundation for differentiation, a service they providing their. So this idea of this hybrid, I thought was kind of interesting.
Yeah. I've been reading a lot the last couple of days about how quickly so many of the LLMs are getting ported to, not just laptops, but like Raspberry Pi, right? It is very clear that that's going to happen very, very quickly. And some of that is just a function of Moore's law, such as it is. But I think that's just embracing the reality. I think that's where a lot of this is headed, is where people are going to want to run this on-prem, if you will, or on their own hardware. And might as well just embrace that and head that way. Because, I think other than, the very, very biggest companies, that's how this is going to get. That's how a lot of people are going to interface with LLMs.
Well, and having a card that is basically positioned to serve, call it a 5 to 200 billion parameter model, that you could run on-prem better than a consumer GPU, but has more of this, like, they're not saying like take this and run a trillion model. They're like, this is specifically for these smaller language models, and it just feels like more organizations will adopt that approach, right, than just licensing tokens and whatnot from a generic system like OpenAI or others. And but to me, again, that just comes back to that's really an empowering position for the organization to differentiate. And again, just democratizing this idea. So these few companies don't have access to these LLMs. It's sort of a bit more democratized. So I thought that was helpful because that's been a big part of the discussion, making sure everybody has
Yeah.
access to these, can use them. It's not limited to the few. And this is part of it. It's early days, but this is part of it.
Yeah, and I think that's well put. And if you think about it, like Moore's law is not dead. I guess Jensen and I agree on this. So we are going to have 3 and 2 nanometer, and once we get there, even today's trillion parameter model will be accessible on fairly basic hardware again. So
Yeah.
you might as well, like, they're aiming where the puck is going to be, kind of stuff.
Yeah. No, I agree. All right. Last question. So coming away from sort of these announcements, are there any? Because this is what I've been trying to figure out, right? I'm trying to not be overly bullish on Nvidia because like there needs to be healthy competition, but even after today, it's like okay, they're even more well positioned. It looks like than they were prior to these announcements. So are there any gaps you think, strategic kind of holes where others might come in and absorb some of this, just to present the counter to the ultimate bullish position? Like what are some of the potential gaps or holes?
Yeah, I recognize this has been little bit of a Jensen love fest. So I in some senses, like GTC, it's a developer conference. It's not necessarily the place where they're going to announce a lot of new products, like really roadmap type stuff. Everything, almost everything today was sort of just like,
Yeah.
here's this thing and here's how it's going to work. Very, very practical as opposed to future. And then you layer on top of that Jensen's proclivity to sort of speak in very visionary terms. Uh, I it's that being said, it's hard to find many gaps. Like in terms of
Yeah.
what we saw today, they just sort of lined up all the pins and knocked them down one by one. Right, here's for
Yeah.
healthcare, automotive, transportation, energy, boom, boom, boom. Right,
Yeah.
lithography, and so I don't think this is the yeah, I didn't see a lot of gaps today. I think we could. I mentioned before there's a lot of questions about the edge and what, if any, role NVIDIA wants to or can play in that. So that's certainly interesting. Um, but beyond that, I'm struggling to think of. I want to find something critical to say, but it's a little
So
tough today.
the only thing, not the only thing, is one thing. Sort of the main thing that hits me is, and it's not today, but I guess it's the one thing I'm watching for, is any vulnerability in the software stack that essentially could relegate Nvidia to a hardware company. They've been smart about this. Like what they did with CUDA was brilliant. I don't know if it was a brilliant accident or if it was strategically brilliant to really do the end goal that it would, which was just make NVIDIA GPUs more valuable. But if there was and this is why, to some degree, I think it's important that they did what they did in foundational models and these more approachable LLMs, because let's say AI gets controlled by Microsoft via OpenAI or Google via Bard, right? You could then see them verticalize their software ecosystem, and then NVIDIA is just the GPU instead of playing role in that software stack. That would be the only thing. Again, not to say and the GPUs get commoditized, but you see where I'm going, right? It's not as valuable if there isn't the vertical software and services stack.
Yeah, I think that's a good point. But that again, I think that speaks to that whole catalog of ships that I mentioned before, where it's like every single partner mentioned, right? They have I mean, every 10 minutes he would stop and just like name a list of companies that were working on this stuff,
Right, right,
right?
right.
And
It's
right,
good
and
to be the
so
king. It's good to be
yeah,
the king.
it's good to be the king. Like they literally have a press release that says NVIDIA works with 100+ partners on healthcare solutions.
Yeah,
Like
yeah. I mean,
so in that context where they're not directly competing with the cloud service providers, they're partnering with them. I think that does speak to like they have an eye on where the business model should be, and
yeah,
I think that you know we can I guess we're going to see like how that value really gets divvied up and how much software revenue, cloud revenue they can really manage. But even if they don't capture AWS like margins on their
Sure.
Omniverse, it's still they've done a lot of the verticalization work, and so they're really well positioned. Now,
Yeah.
just saying that, it occurs to me they didn't actually talk much about Amazon. They talked a lot about Google and a lot about Azure, but I don't know that they mentioned
Microsoft.
AWS once.
I'm blanking. If they did, it wasn't brief passing, but I think you might be right. Um, it is interesting. I mean, at some point in time, we should just do one on Amazon to see. Our friend Dylan wrote an interesting piece about how AWS is in troubling a troubling position. I mean, I think he straight said they're going to lose the AI war, but I wouldn't like go that far. But it is interesting to see what bets are being placed. But it
Yeah,
was definitely not a highlight. Google, Microsoft, you can tell like they are all in. Nvidia is all in with those two companies.
yeah, and especially if you think about like AWS actually has a training chip. It has Trainium, and it has Inferentia. And
Yep.
as far as I know, those are both first generation, but as far as I know, they're actually working on second generation silicon. So they must be seeing something like. I don't,
Right.
from everything I can see, they're not actually gaining much share in the training market. But
Yeah.
they don't need a lot because they have their own workloads they can run on Trainium. But it is going to be interesting to see how AWS plays in all this and
Yeah.
why they weren't there this year. They clearly think they didn't need to be,
Yeah.
didn't want to be, or who
Yeah.
knows? Maybe they're just negotiating a contract and they're they didn't sign it in time to get a keynote slot.
But they definitely need to get into the limelight in some way. I mean, just what they did with Hugging Face is not alone in my by itself enough, in my opinion. So,
Yeah.
AWS has got to get into this conversation. All right, I said that was the last question, but last question, just because I'm going to put you in the spot for our investor audience. As we speak, Nvidia's PE is 111.49. Is this company undervalued at that PE?
What are numbers? 100 PE. What's a number? It is. I mean, in order for them to live up to that valuation, this has to be the first semiconductor stock to hit $1 trillion
A
market cap.
trillion. Yeah, a trillion. Yeah.
So let's think, what would it take to do that? They would need to win a lot more in the data center. And so that's probably working in their
Inference.
favor, right? We have
Yeah.
big CPU shift to heterogeneous compute.
Yep.
It's a
Yep.
lot of wallet opening up for GPUs. Um, we probably have to see that accelerate, which may happen with all this GPT stuff and all these LLMs coming out. You may see an even more radical shift to, let's go crazy. Let's call it 50% GPU in the data center. Um, those look hard to do. It's not impossible, but it's a little heroic. Uh, so yeah, from a pure math standpoint, yeah, it's hard to get to this being, it feels a little expensive,
Yeah.
but strategically they look like they're in really good shape. And certainly
Yeah.
anything in the data center, like they just have such this huge portfolio in the data center.
Yep.
It's and right, and cloud is gonna cloud's gonna keep growing for
Yep.
for a while.
Yep.
So they look pretty well positioned for that.
Yeah. No,
I think their
I
I think their big gap is automotive because autonomy is not coming anytime soon.
right.
That's the one sort of flaw in their armor.
Yeah. And even then that might be more of a back end play than a win on the automotive on the cars themselves. But I mean, I think the interesting thing is right. They're what 30 billion ish a year right now. I mean, you could make the case that could grow, that could double. That doesn't necessarily put you at a trillion, but over time, they have it what looks like a roadmap to increase demand of GPUs. The CPU stuff I think will be interesting to really see. I mean, we got a glimpse of Grace Hopper today. You could imagine that they go full assault on x86 with ARM-based CPUs and take over the ARM, or try to take over the ARM-based CPU market itself. So there's path, but I agree with you. I mean, getting to $1 trillion outside of, again, just people pouring money in them and increasing their PE to get inflated, which could happen, but they are very dominant at the moment. So
just to be clear, I was just saying, just to be clear, I think they will hit that $1 trillion valuation, but it won't necessarily be justified by fundamentals.
Yeah, agreed. But the street likes dominant companies. I'm not using the M word in this case, but the street likes dominant companies. All right, Jay. Good chatting on NVIDIA. Until next time, thanks everybody for listening.
Thank you, everybody.